Recently, a discovery has captivated the attention of scientists and space enthusiasts alike. Bill Nye, a well-known science communicator, made headlines when he announced that Voyager 1 had detected 300 massive objects in space. This revelation has not only ignited our curiosity, but has also raised profound questions. What exactly are these things, and where exactly did they originate? Join us as we delve into the mysteries hinted at by Voyager's astonishing findings. For nearly 5 decades, the Voyager missions have provided some of the earliest and most extraordinary views of solar system wanderers. Surprisingly, these missions weren't designed to last this long. Back in the 1970s, Michael Minovich had a groundbreaking idea. The velocity of a planet could be used by a spacecraft to propel itself deeper into the solar system. Originally intended to last only 5 years, the Voyager mission has far exceeded those expectations. Launched just weeks apart in the summer of 1977, Voyager 1 and Voyager 2 were first tasked with exploring Jupiter and Saturn. They accomplished this by providing detailed studies of these giants. However, the journey did not end there. Voyager 2 went on to conduct the first-ever close-up observations of Uranus in 1986 and Neptune in 1989. These historic flybys of 4 planets earned the mission the title Voyager Grand Tour. Instead of ending, the resilient spacecraft set their sights on a more ambitious goal, exploring deep space. Now, 45 years later, both Voyager 1 and Voyager 2 are still traveling and collecting crucial scientific data from the distant regions of the cosmos. In 2013, NASA made a groundbreaking announcement. Voyager 1 had officially entered interstellar space, the region between stars that is not affected by the sun's magnetic fields or particles. It's like leaving the busy solar system and stepping into a serene, star-filled wilderness. This journey continued in 2018 when Voyager 2 also crossed this vast region, located 17.7 billion kilometers from the Sun. Astonishingly, Voyager 1 and Voyager 2 remain the only spacecraft to have ventured into interstellar space, where they study how the interstellar medium interacts with the solar wind from our Sun. These pioneering missions have been our primary source of information about the heliosphere, a protective bubble that surrounds and shields our solar system. The heliosphere, shaped and influenced by solar wind, a continuous stream of charged particles from the sun, acts as a protective barrier for our solar system. Both Voyager 1 and Voyager 2 have served as our cosmic messengers, relaying valuable information about this celestial shield. All of this data converges at the heliopause, the outermost boundary of the solar system, marking the transition between the solar wind and the vastness of interstellar space. NASA's Voyager spacecraft have given us new insights into interstellar space. One significant discovery is that of cosmic rays, mysterious, high-energy particles that are 10 times more intense beyond the heliopause than within the safer confines of the heliosphere. It's like comparing the calm of a quiet backyard to the busy energy of a bustling street. But there's more to this cosmic story. NASA didn't stop with Voyager. Findings, by combining data from later missions with Voyager's observations, created a more complete picture of how the sun interacts with the surrounding interstellar space. In this grand cosmic dance, scientists made an unexpected discovery. In 2023, Voyager 1 detected a faint, low humming sound that corresponded to the vibration in a small amount of gas drifting through interstellar space. The head of NASA's Heliophysics Division, Nicola Fox, emphasized the significance of the Voyager missions, stating that they have transformed our understanding of the sun in ways that no other spacecraft has done before. This incredible adventure in space is even more impressive considering the Voyager's power limitations. Both spacecraft are powered by a plutonium-based system. However, as the plutonium decays, it generates less heat, gradually depleting the spacecraft's energy. NASA must make difficult decisions to meet this challenge, such as turning off systems that aren't necessary and even heaters that are meant to keep instruments warm in the icy vacuum of space. Astonishingly, despite these challenges, all 5 key instruments have continued to function since 2019, defying all expectations. NASA scientists remain baffled by how the Voyagers are still operating under such cold conditions, where other spacecraft would freeze. The legacy of these remarkable space pioneers, whose journeys continue to astonish astronomers and advance our understanding of the farthest reaches of our solar system, is further enhanced by this mystery. The heliopause, which marks the boundary between the Sun's influence and interstellar space, isn't static. Instead, it is shifting and forming unusual angles, leaving scientists both intrigued and perplexed. The idea that the heliopause might change shape isn't entirely new. Over the past decade, researchers, using data from Voyager 1 and Voyager 2 and NASA's Interstellar Boundary Explorer, IBEX, satellite, have observed its tendency to shift. These spacecraft provide crucial direct measurements of these cosmic boundaries, even if they can only capture a snapshot of a single location at a specific time. Dr. Eric J. Sarin, a space physicist from Princeton University, shared his excitement. In an email to Vice, noting that the Interstellar Boundary Explorer, IBX, has been supplying valuable data, helping scientists redefine their predictions about the heliopause's future movements. What makes things even more intriguing is that recent studies have challenged long-held assumptions. In 2014, IBEX detected an unusual brightening of energetic particles, hinting at irregularities in the heliopause. However, these anomalies didn't fit current models, almost like an unexpected twist in the story. Researchers also noticed substantial shifts in the heliopause's position over a short period of time. Despite a gap of 6 years, Voyager 2 entered interstellar space in 2018, and Voyager 1 entered interstellar space in 2012. Not only are these unexpected findings perplexing, but they also go against what scientists thought they knew about the heliopause. In a recent article in Nature Astronomy, researchers described these discrepancies as the entry speaking, indicating that they can raise questions and could spark a debate within the scientific community. However, the search for answers goes on NASA's upcoming Interstellar Mapping and Acceleration Probe, IMAP, scheduled for launch in 2025, promises to uncover more secrets about the outer edges of our solar system. Meanwhile, the mysteries persist. In May 2023, Voyager 1 experienced an unusual event during its operations. The spacecraft's Attitude Articulation and Control System, AACS, which manages the direction of its high-gain antenna, began to send back confusing data. Instead of the regular updates of its health and studies, it seemed like Voyager 1 was struggling to communicate, almost as though it were experiencing something akin to electronic aphasia, a kind of communication confusion. Voyager 1 appeared to be having issues with its electronics from Earth's perspective. The data Voyager 1 sent back during the recent anomaly seemed random and incoherent, as NASA described at the time. Interestingly, despite these strange reports, Voyager 1 itself appeared to be functioning normally. Its radio signal remained strong and stable, indicating that the antenna was still pointing toward Earth, contrary to what the AACS was suggesting. Adding to the mystery, Voyager 1's scientific instruments continued operating smoothly, unaware of the AACS malfunction. The spacecraft's fault protection system, which was meant to put it in safe mode in case of problems, was not even activated. Fortunately, NASA quickly discovered the problem. The AACS had been using a computer that had been inactive for a long time. The solution was easy to find. For data transmission, they issued a command to switch to a functioning computer. However, the cause of the AACS's strange behavior remained unclear. NASA speculated that an incorrect command from another onboard computer might have caused the issue. While this event didn't, to endanger Voyager 1, NASA continues its investigation to avoid future issues similar to this one. For more than a decade, Voyager 1 has been exploring interstellar space, away from the sun's protective magnetic field. Spacecraft are shielded from cosmic rays and radiation by this field, similar to Earth's magnetic shield. It functions like a cosmic armor suit. As with technology on Earth, Voyager 1's onboard computers occasionally face challenges from high-energy particles in space. These energetic particles can occasionally interact with computer chips, resulting in minute memory errors that build up over time. A broader perspective on these difficulties was provided by Susan Dodd, the project manager for both Voyager 1 and Voyager 2. She explained that encountering such anomalies is expected at this age of the mission, considering that these spacecraft have been on an extraordinary journey for nearly 5 decades, which is significantly longer than their original mission duration. Now navigating the uncharted territory of interstellar space, where radiation levels are high, the Voyagers face a range of cosmic hurdles no other spacecraft has ever encountered before. Nearly 50 years have passed since Voyager 1 and 2 embarked on their historic journey, crossing immense distances and exploring the unknown. NASA has kept these far-off explorers running, despite the fact that their 1970s computer system only had 70 kilobytes of memory. Just imagine the effort involved in sending software updates across vast cosmic distances. In the vast, dark expanse of space that lies billions of miles from Earth, ensuring that the Voyager spacecraft continues to function similarly entails providing support for IT in the cosmos. These legendary probes continue crossing major thresholds, offering profound insights into the mysteries of our solar system. Let's take a moment to appreciate these pioneers who set the standard. The twin Voyagers, now drifting endlessly among the stars, each about the size of a small car, represent the technological spirit of the 1970s. The Voyagers have left an indelible mark on every celestial body they have explored, despite their outdated computer systems, which are less powerful than digital watches of today, and their analog television cameras, which appear more primitive in comparison to those of today. We have discovered astonishing information about the planets they visited as a result of these spacecraft. For instance, Jupiter was shown to be more than just a placid gas giant. It was also shown to be a world of extremes, with hundreds of fierce hurricanes, glowing auroras at its north pole, and intricate ring systems that no one had ever seen. It was discovered that Saturn had thousands of delicate ringlets, some of which were braided in ways that scientists had never imagined. Previously, it was thought that Saturn only had a few simple rings. Even more surprising were the revelations from the moons. Jupiter's moon Io displayed active volcanoes, an extraordinary find that changed our understanding of geological activity beyond Earth. Despite its near-zero surface temperatures, nitrogen geysers were observed erupting from Triton, Neptune's moon. These phenomena offered a glimpse into the dynamic nature of worlds once believed to be frozen and lifeless. The hints at possible alien life were perhaps the most enticing of all. The icy crusts of 2 moons, Europa on Jupiter and Enceladus on Saturn, were found to contain subsurface oceans. These vast, salty oceans, kept liquid by tidal heating, might provide the perfect environment for microbial life. As a result, future missions looking for extraterrestrial life have made them prime targets. But when Voyager captured the now famous image of the pale blue dot in the early 1990s, it was its most moving and enduring moment. One of Voyager's most important visionaries, Carl Sagan, suggested that Voyager 1 turn its camera back toward Earth. Earth appeared to be a tiny speck, like a pale blue pixel suspended in a sunbeam from more than 6 billion kilometers away. It was intended for us to be reminded of our fragility, our unity, and our place in the cosmos by taking this humble image from a distance that was more than 100,000 times greater than any human had ever seen Earth before. As Sagan famously reflected, "Look again at that dot. That's here. That's home. We are that." There, On a bed of dust suspended in a sunbeam lived every saint and sinner in human history. Both Voyagers have continued to drift further away from home ever since. Because of the immense distance between Voyager 1 and Earth, it takes Voyager 1's signals over 22.5 hours to reach us. Signals from Voyager 2 take nearly 19 hours. Even at the speed of light, communication is a long-haul conversation across the void. Despite the delay and the weakening signals, NASA's Deep Space Network, with its massive radio antennas positioned strategically around the globe, remains in contact with these spacecraft, still listening to their faint whispers across the cosmic silence. Their messages continue to shape our understanding of the universe as the Voyagers venture into unknown interstellar space. Their resilience is a testament to human ingenuity and curiosity, qualities that remain at the heart of space exploration. The Voyagers are a symbol of the enduring spirit of discovery, and despite the fact that other spacecraft may arrive and depart, they have made their mark on history. The mission that began with planetary exploration has become something much larger, a story of survival, legacy, and the pursuit of knowledge, no matter how distant the horizon.